I told you to check this part, this we did in the last semester, the concept. In the left-hand side, we are considering the total effect. Now, when we are considering the Slutsky equation, we can consider the change in price with respect to the same commodity, or we can consider the change in price with respect to the cross commodity. So here the typical equation is in terms of the cross commodity. However, the same equation I could write in terms of xi, that is del xi by del pi, then is equal to del xi by del pi. That del xi by del pi is a typical del xi by del pi which considers only the substitution effect. And then I can consider del xi by del pi, which is related to income effect. Again, there will be a change in quantity demanded due to change in price. However, this part is coming through income effect channel. Price is changing, that is affecting the real income, and for that matter, the demand is changing. Okay, so this is solely due to change in price, and this part is coming from the part that when price is changing, that is changing our relative income. So that is changing our purchasing power. And from that source also, there will be some change in demand. So today, we will try to derive this equation using the mathematical concepts, Now, derivation of Slutsky equation is based on the comparative static demands. Now, comparative static demand means, we have to start with the value function. So as if I have maximized utility subject to budget constant and got the values of x1 star and x2 star, which are functions of P1, P2, and M. In a two commodity world, there are two commodities. Naturally, there are two prices, P1 and P2, and consumer's income is given by M. So once I have this optimized amount, from there we will derive the Slutsky equation, because once we have this optimized amount, which is function of parameters, then only we will be able to start a discussion based on comparative statics. Okay, so the first step, substitute solution to the optimization problem. That is the Marshallian demand functions and lambda Lagrangian multiplier. So substitute solution to the optimization problem back into the first order conditions. So we have to start from the utility maximizing solutions, that is from the value function where there is Lagrange multiplier. So it is indicating the constraint utility maximization context. Now, in this Slutsky equation, Slutsky considered the first order conditions are identities. Instead of considering the equations, since it is based on the value functions, Slutsky considered these equations, same equations, as identities, because already the things are derived. So, identity, he considered the matters as identities. Solutions to the first order conditions are defined so as to make those conditions equal to 0. This because already we discussed a number of things based on bordered Hessian determinant. So, already you are familiar with the first order conditions, second order conditions, etc. So we have the utility function, which is a value function, which is functions of P1, P2, and M, which are functions of P1, P2, and M. So if I write the first order conditions, considering equivalence, the first order condition was del U by del x1 minus lambda P1 equal to 0. This was the first order condition. Can you remember this, the first order condition? Anyone, any problem? Please ask me. Otherwise, please confirm whether you are understanding this is the first order condition. This is the derivative of utility with respect to the first commodity x1. When we took the derivative with respect to the first commodity, we had the Lagrangian expression, then we considered del L by del x1. So are you understanding? This is the expression for del L by del x1.
Yes, ma'am.
Yes, ma'am.
Okay. Others, Are you understanding? This is the first order condition. You know, the first order condition that was sorry, del u by del x1 minus this was the thing. Okay. Now instead of u, now we are considering u star. Okay, the value function, which is a function of P1, P2, and N. So the way we have presented, you know, this P is the P vector. Here, the set of P1 and P2. This is a vector. Consisting of two prices, P1 and P2. Okay, so same first order condition I am writing, just incorporating the notion of value function. X1 and X2 are no more the original quantities of original first order condition. These are X1 star and X2 star basically, which are functions of P1, P2, M. So if you understand the first equation, then you know I'm writing the second equation as well. And please check the second part as well. Lambda also I'm considering in terms of function in terms of P1, P2, M. So by this time, you know, you checked the idea of lambda, the Lagrange multiplier. You checked the different interpretation of lambda. And I hope you are understanding lambda is also function of P1, P2, M. In our comparative static analysis, we got the interpretation of lambda in terms of del lambda by del M. All these things happened. So lambda is also a function of P1, P2, M. Actually, when we consider the first order conditions, we take the first two derivatives with respect to x1 and x2, and then we take the derivative with respect to lambda. So the way we are deriving x1 star and x2 star following the same mechanism, we can derive the value of lambda star, and naturally the lambda star will be function of P1, P2, and N. Okay, so I'm writing the expression in this way. Second equation I hope is understandable. And coming to the third equation, when we take the derivative with respect to lambda, we get back the constant term. So we are getting m minus p1 x1 minus p2 x2. This equation, m is equal to p1 x1 plus p2 x2. That equation we are getting back. So that equation I have written. The way I have written the third equation, you know, so that it matches with the earlier two, because our objective will be to apply the Kramer's rule here and find out the income effect, price effect, all these things. Okay, so I'm following a pattern, you know, the x1, x2 component I'm keeping first, and then I'm writing keeping the rest of the terms.
Ma'am, above P, is there a hat?
No, there is no hat. It is simply P. If it is hat, everywhere it will be hat. আমি যেভাবে মার্ক করেছি ওরকম একটা হয়ে গেছে। You know, I wanted to make a circle to tell you this is a vector. You know, there is no hat in it. It is a set. You know, just look at the second line I have written here. P implies the combination of all prices. It is basically a vector of prices. Vector consisting of all possible prices. ঠিক আছে?
Yes, ma'am.
By definition, the endogenous variables respond to changes in the exogenous variables by adjusting to keep these equations identically equal to 0. Okay, endogenous variables means x1 and x2 respond to changes in exogenous variables means p1, p2, and m, by adjusting to keep these equations identically equal to 0. So we can take derivative, etc. However, it will maintain the basic structure of these identities, of all these three identities. Second step, we can use derivatives of identities to measure the way in which endogenous variables respond to changes in the exogenous variables. That is, derive comparative static results. Comparative static result means we can take the derivatives with respect to change in M, we can take the derivatives with respect to change in P1, we can take the derivatives with respect to change in P2, and can finally derive the Slutsky equation. So let's first talk about income effect. Okay, that is, we will differentiate all the equations, all the first order conditions, all these three first order conditions. We will take derivative of all these first order conditions with respect to M. We'll take derivative of all these three first order conditions with respect to M. Okay, so I hope everybody has pen and paper. So please take derivative of first two identities with respect to M. First, you start with the first identity. Take derivative with respect to M. Please check the fact that U1, that is the del U by del X1, that is also a function of P1, P2, M. Okay, so while you are taking the second derivative, while you are taking the derivative of this first order condition with respect to M, please remember that both x1 and x2, these are functions of M. So U1 is function of M, lambda is function of M. So everything is function of M. So would you please take the derivative with respect to M? Once any one of you get the result, please share the result.
Ma'am, will I say?
Yeah, definitely. I'm waiting.
U11
Slowly. U11
del x1 by del m
del x1 by del m.
plus U12
U12.
del x2 by del m
Yes.
minus P1 del lambda by del m equal to 0. Then
Okay.
next,
Rest of the students, are you getting these things? If there is any mismatch, if you don't get this value, please let me know. Yes, next.
U21 del x1 by m plus U22 del x2 by del m minus P2 del lambda by del m equal to 0. Then minus P1 del x1 by del m minus P2 del x2 by del m plus 1 equal to 0.
So everybody is getting this? Very, very good.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, very good. So let's check the things. Okay, so you got these expressions. U11 del x1 by del m plus U12 del x2 by del m minus P1 del lambda by del m. Okay, this thing, then u21 del x1 by del m plus u22 del x2 by del m minus p2 del lambda by del m equivalent to 0 minus then p1 del x1 by del m minus p2 del x2 by del m plus 1 equivalent to 0. Okay, so same set of equations are written. Now, once this thing is written, will you be able to find out del x1 by del m and del x2 by del m using the Cramer's rule?
Yes, ma'am.
So everybody completed up to this?
Yes.
Others got this result?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. So, now we have to use the Cramer's rule. Or equations are linear in partials, and in terms of matrix algebra, we can present the thing in this format. Okay, so please write down the equations in this format. Equations are linear in partials, partial derivatives we are using. And using matrix algebra, we can write this in this format. Why I am writing this in this format? Because the first term, are you familiar with this first term? Are you familiar with this first term? Are you understanding something? Looking at the first matrix?
Yes, ma'am.
So what is it?
Coefficients.
Coefficient মানে bordered Hessian determinant টা নয় এটা bordered Hessian determinant যে ম্যাট্রিক্সটা থেকে হয় সেটা নয়
Yes, ma'am. Yes, ma'am.
তাহলে এটা হেসিয়ান ম্যাট্রিক্সটা হ্যাঁ bordered Hessian matrix bordered Hessian matrix. So please write down the equations in this format. And then solve for del x1 by del m and del x2 by del m. So first, what we have to check before using Cramer's rule, what we need to check? What is the precondition for applying the Cramer's rule?
Determinant exists.
Non-singular matrix.
So which matrix will be non-singular matrix?
Bordered Hessian.
Yeah. So bordered Hessian matrix should be non-singular matrix, and for that we check the determinant. Now here we will be able to use the condition we know by the quasi-concave nature of the utility function. We can ensure what will be the sign of the determinant, or by strict convexity of the utility function. Better to say quasi-concavity of the utility function. What will be the sign of the determinant? Positive, negative, what will be the sign?
Less than.
Positive.
Positive. In case of maximization, remember that the sign will be positive. In case of, actually the sign will alter, starting with positive. However, since I am considering a 2x2 construct, this sign will be positive. In case of negative, in case of minimization, all the determinants will be, or all the principal minors will be negative. So here alteration in sign starting with positive, and in our case it will be positive because this is the first cofactor. Okay, so if I want to find out del x1 by del m, In the denominator, I'll have this, and please ensure this is positive by the second order condition of utility maximization. This determinant is positive by the second order condition of utility maximization. And find out the numerator. You have the equations, so you will be able to find out the numerator. So what will be the first column of the numerator?
0,
0,
1.
0, 0, 1.
For del x1 del m, right?
Del x1 by del m. You are deriving
Yes,
del
ma'am.
x1 by del m. You are deriving income effect.
Yes, ma'am. So 0, 0, 1.
0, 0, 1. And then write down the other two columns. What will be the second column?
Q12, U22 minus P2.
Very good. U12, U22 minus P2. And what will be the third column?
Minus P1 minus P2 and 0.
Minus P1 minus P2, 0. Is she all right? Everybody is getting that?
Yes, ma'am.
Yes, ma'am.
Okay, very good. Okay. So this is the structure 0, 0, 1, U12, U22 minus P2 minus P1 minus P2, 0. That is the numerator. So please solve for the numerator. Denominator you don't touch because here I have used a notation capital D, so, or you can write down H bar, det H bar, bordered Hessian determinant. So this is nothing but the bordered Hessian determinant. So you can consider any notation. And that is greater than 0 by second order condition. So solve for the numerator and check whether you are getting minus P1 U22 minus within bracket P1 U22 minus P2 U12. Please check it.
Ma'am, shouldn't it be minus P2 U12 plus P1 U22?
P1, U22. Yes, ma'am.
There will be no minus sign that you are telling.
Yes, ma'am. Basically, P1 U22 will be positive and will have a positive sign, and like P2 U12 will be negative.
But ma'am, this is also
Yes,
correct.
ma'am.
Because the minus is outside, so it becomes the same thing.
ওরা তো বলছে যে প্লাস P1 U22 আর
Minus P2 U12.
Ma'am, it is 0, 0, minus 1. How are we getting 1?
তুমি তো এদিকে রাখছো, তাই না?
Ma'am, matrix equation টা একবার দেন না।
0, 0 minus. Yes. যখন তুমি এটা বসাচ্ছ তাহলে আমার এখানে একটা -1 নেবার কথা, তাই না?
Yes, ma'am. Then yes, ma'am. Then we are getting this value like for the one that's on the slide.
-1 বসবে। এটা একটু ঠিক করে করো। এটা সবারই তো তাহলে 0, 0 -1ই হবে, তাই না?
Yes, ma'am.
এখানে আমার একটা টাইপো আছে, সো ইট উইল বি this. Okay, is it okay now?
Yes, ma'am.
Yes, ma'am.
Now, what will be the sign of these income effect? Um, it is written that it can be less than 0, it can be equal to 0, it can be greater than 0. Okay, because you know that if the commodity is a normal good, in that case, as income increases, quantity demanded will increase. As income falls, quantity demanded will fall. Okay. Now, when the commodity is an inferior good, in that case, as income increases, quantity demanded falls. As income increases, quantity demanded falls. So in that case, it will be less than 0. And if there is no income effect, that is, it is income inelastic demand. Okay, only the substitution effect is possible. Income effect is not possible. Because of change in income, there will be no change in consumption. That is also possible theoretically. Totally income inelastic demand. So in that case, the value will be equal to 0. So del x1 by del m can be negative, del x1 by del m can be equal to 0, del x1 by del m can be positive. Okay, so denominator is always positive. However, the numerator can take any of these three possibilities: less than 0, equal to 0, greater than 0. Is it all right that it can take all three possibilities are there? Is it all right to everyone?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, so next,
Yes, ma'am.
okay, next we have to find out del x1 by del p1, del x1 by del p1. Because if we look at the Slutsky equation, the theoretical construct, we are not only considering a change in demand due to change in income, but also we have to consider the substitution effect. That is change in demand due to change in price. Okay. So to construct the Slutsky equation, first we are deriving the income effect part, that is the del x1 by del m part. I'm considering commodity 1. At this moment, you can do the similar exercise considering commodity 2. In that case, you have to find out del x2 by del m. So for both the commodities, we can derive the income effect using these steps. However, to derive the Slutsky equation, we need to calculate del x1 by del p1. Slutsky equation can be derived in terms of own price, in terms of cross price. Okay. So you can use also del x1 by del p2 to construct the Slutsky equation. So it can be constructed using the own price. In that case, you have to derive del x1 by del p1. If you like to write the Slutsky equation in terms of cross price, in that case, in the next step, you will find out del x1 by del p2. So it depends on the question, or it depends on the context, whether with respect to own price you are deriving the Slutsky equation, or whether with respect to cross price you are deriving the Slutsky equation. Okay, so in this way, for x1 you will be able to derive two Slutsky equations. First version for own price, the second version for the cross price. Then following the same mechanism, you will be able to find out the Slutsky equation for x2. In that case, you have to start with del x2 by del m. Here we are starting with del x1 by del m. We are finding income effect for commodity 1. So you can start with income effect of commodity 2. And then you can find out del x2 by del p2. If you like to write the Slutsky equation for x2 in terms of price of x2, and if you like to write the Slutsky equation for x2 in terms of price of x1, in that case you need to find out del x2 by del p1 and write the Slutsky equation. So there are four possibilities in the two commodity world, 2 for x1 and 2 for x2. And when we are considering these two equations, one for own price and another for cross price. So please tell me whether you are understanding, what are the possible forms of the Slutsky equation we can derive in a two commodity world? First tell me whether you are understanding or not, or whether I need to repeat.
Ma'am, please repeat once again.
Okay. Okay, so just so what I'm telling that first I'm deriving income effect. And then I'll consider substitution. Okay. Now for this part, I can consider the matter with respect to own price. I can consider the matter with respect to price of the other commodity. So if I start with, say, first commodity, X1. So for X1, where total effect will be considered in terms of own price. Okay, so here, when you will calculate the AC part, you have to consider the derivative of X1 with respect to P1. Okay, so for this part, then del X1 by del M part will be there. Alternatively, sorry, in that case, you are considering the total effect in terms of cross price. So when you will go for the substitution effect calculation, this part will remain unchanged. Okay. So similar two possibilities are there for the commodity X2. And instead of X1, if we consider X2, one is del X2 by del P1, and another possibility is, okay, so income effect derivation part remains unchanged. Okay, so these are the four possibilities. With respect to own price, you can derive the Slutsky equation. With respect to cross price, you can derive the Slutsky equation. You may be asked to derive the Slutsky equation for commodity 1. You may be asked to derive the Slutsky equation for commodity 2. So all these possibilities are there. Is it now clear? We are doing one possibility in the class, rest you have to do on your own. Is it understandable? Are you understanding?
Yes, ma'am.
Yes, ma'am.
So in the next step, we will find out, own price effect. Okay. So we have to do the same thing. This kind of equations we need to generate with respect to P1. So starting from the utility function, please generate, starting from these first order conditions, please generate the set of 3 equations taking derivative with respect to P1. So now I'm considering the effect with respect to own price. So please take derivative with respect to P1. Once you get it, please tell me. I'll write down the equations. Both U1 and U2 are functions of P1 and P2. Lambda is also function of P1 and P2. So these are the first order conditions. This you have to take derivative of these first order conditions with respect to P1. The second expression is in U into V form. Lambda is a function of P1 and then there is into P1. So, yeah, so somebody could complete it. Would you please tell me the equation, the derivatives?
Ma'am, del U1 by del X1
Yes.
into del X1 star by del P1.
Del U1 by del X1. So in that case, better to say
U11. Yes, ma'am.
U11
Into del X1 by del P1
yes,
plus U12 into del X2 by del P1 minus del lambda by del P minus lambda equals to 0.
everybody is getting this?
Yes, ma'am.
Good. What will be the second equation? Anyone? Please tell me.
U21
One.
del x1 del p1 plus u22 into del x2 del p1 minus p2 into del lambda del p1 is equal to 0.
आगे del lambda का बोले ना तो?
Del lambda del p1 into p1.
हाँ?
p1 into del lambda del p1.
ম্যাম এটা P2 আছে তাই ইস্যু হবে না মানে
Yes, ma'am,
P2
P2
into del lambda by del P1
is equal to 0.
এটা P2 হবে তাই না?
হ্যাঁ ম্যাম and ম্যাম ফার্স্ট ইকুয়েশনে del lambda by del
Yes.
P1
Yes, ma'am.
into P1 হবে
Into P1. Oh.
এইখানে sure. এখানে তো P1 into ছিল, P2 into হলো মাইনাস, বলো কি আছে নেক্সট?
Equal to 0.
এখানে তোমার ইকুয়াল টু 0। Next বলো।
Ma'am, minus
minus
P1
P1 into del x1 del
del
P1
x1 by del P1
minus P2
del x2 by del P2.
is equal to x1.
Yes, ma'am.
This one.
Yes, ma'am.
So from এখানে del x2 by del p2 হবে না, p1 ই হবে। এখানে একটু গন্ডগোল। তাই না? p2 হবে না।
Yes.
এবার এটাকে ওই সিমিলার ফরম্যাটে লিখে নাও। These are linear in derivatives, so আগে একটু চেক করে নি এভরিথিং। u11 u12 minus p1 ঠিক ছিল, u21 u22 minus p2 minus p1 ঠিক আছে, ঠিক আছে। এই ফরম্যাটে করে ফেলো। I hope signs are all right. I checked, you know, it will be best if you also check the things. The equations are here, and from this equation we are for writing the things in this format. So if there is any mismatch, if somebody could not complete this part, please tell me. This will be the derivatives, and just we are writing the derivatives in this format, in the matrix format. And then following the same style, find out del x1 by del p1. Find out the value of del x1 by del p1, del x1 by del p1. If anyone have any question, please ask me. For when you will use the Kremes rule, again in the denominator you will get determinant of this bordered Hessian part, and by the second order condition of utility maximization, it will give you the value positive. So follow the same mechanism.
Ma'am, can you please show the equations again? I need to check the last equation once. Yes, ma'am. Thank you.
Ma'am, I found del x1 by del p1.
Please tell me the value.
Ma'am, if the value is lambda in brackets minus P2 square plus x1. Ma'am, bracket close. Bracket close.
Minus P2 square bracket close.
Yes, ma'am. Plus
Plus
x1 in brackets minus P2 U12 plus P1 U22 bracket close by the determinant.
or by D. সবার নিউমারেটরটা এরকম হচ্ছে?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
মানে এইটা তাহলে নিউমারেটর, এইটা কি সব মিলিয়ে নেগেটিভ হচ্ছে? একটু ভালো করে চেক করো তো নেগেটিভ হচ্ছে কিনা। আমি একটু চেক করে নিই। মাইনাস ল্যামডা p2 স্কোয়ার x1 এটাই ছিল, তাই না?
Ma'am, why this is negative?
Substitution effect তো তোমার, if I consider the change in demand due to change in price, তাই না, নেগেটিভ সাইনটা আমি এনশিওর।
Ma'am, is it substitution effect or total effect?
কি বলছো?
Ma'am, is it substitution effect or total effect?
This is the price effect. This is the price effect. This is not exactly, I cannot call it the substitution effect in the sense, because this is not the cross commodity. This is with respect to price of that commodity only. So I am checking the matter, what is the direction of the sign, etc. that I am asking for. Okay, so I hope you got this result. Everybody got this result?
Yes, ma'am.
Yes, ma'am.
So the last term, that is minus P2 U12 plus P1 U22, that is equivalent to this one, right? No? Del x1 by del n.
Yes, ma'am.
Okay. So what Owen is telling, we can put the matter in this way. So del x1 by del p1. So in that case, it is the total effect of relative price change. If I split the things in this way. So del x1 by del p1 is equal to minus lambda p2 square by d. That component will be there. And this component is negative. Lambda is the Lagrange multiplier, which is positive, p2 square positive, d positive. So this part is negative. Minus, we are getting x1 into del x1 del n. So this is the required Slutsky equation, where the first term in the right hand side indicates the substitution effect and the second term indicates the income effect of relative price change. Owen, you are absolutely right. So we are getting the total effect of price change when we are taking the derivative del x1 by del p1. The first component is the substitution effect. The second component is the income effect. The first component that will be negative because here we are considering the change with respect to price of that commodity only. So it should be negative, and we are getting the negative value. Lambda, P2 squared, D all are positive. So the first component is negative, and the second, will depend on what is the sign of del x1 by del m. If it is a normal good, the sign will be positive. If there is no income effect, 0, and if the commodity is an inferior commodity, in that case it will be negative. Okay, so this is the Slutsky equation. Now the similar exercise, as I mentioned, can be done considering the derivative del x1 by del p2, del x1 by del p2. The second part will remain unchanged because this part is same for both the contexts. This part is same, so you don't need to calculate this part. You need to construct only this part where you have to take the derivative with respect to p2 only. Okay, so once you do that, you will be able to write the Slutsky equation in terms of cross price. That is, that will be del x1 by del p2 is equal to the substitution effect plus income effect part. Okay, so I think it will be better if you complete that derivative too, derive del x1 by del p2, and for x2 you will do everything in your home. So give, write the section C, subsection C, cross price effects, cross price effects. Okay. So you have to take derivative of all first order conditions with respect to P2 down. Take the derivatives of all first order conditions with respect to P2. Could you complete this thing?
Yes, ma'am.
Yes, ma'am.
Follow. U11 or what will be the thing?
U11 del X1
Little louder.
U11 into del x1 by del p2 plus U12 del x2 by del p2
U11
del x1 by del p2
del x1 by del p2
plus U12
U12
del x2 by del p2 minus p1 del lambda by del p2 equivalent to 0.
Okay.
Second equation U21 del x2 by del p2 plus U22 del x2 by del p2 minus lambda minus p2 into del lambda by del p2 equivalent to 0. Last equation minus p1 del x1 by del p2 minus p2 del x2 by del p2
equals to X2.
equal to x2. Ma'am, in the second equation that u21 del x1 by del p2, I said it wrong.
Last equation minus p1 del x1 by del p2 minus
It's equivalent to x2.
Equal to X2.
আচ্ছা সেকেন্ড ইকুয়েশনে বলো কি হয়েছে
Ma'am, u21 del x1 by del p2.
হ্যাঁ yes so rest of the students are you getting this
Yes, ma'am.
get this thing
Yes, ma'am.
from,
Yes, ma'am.
from these three equations you find out
Ma'am, I got the result.
yes one
Numerator lambda p1 p2
আস্তে আস্তে lambda
into p1 into p2
yes
plus x2
yes
bracket minus p2 into u12 plus p1 into u22 bracket close, and in the denominator there is a determinant.
the same determinant
Yes, ma'am.
Yes, ma'am.
okay so everybody is getting this
Yes, ma'am.
Yes, ma'am.
let me get this okay so this is the final result okay you got the thing and then in this equation you check whether you got the value for del x1 by del m del x1 by del m that is minus p1 u22 minus p2 u12 sorry plus p2 u12 so are we getting one part which is equivalent to this
Yes, ma'am.
so in this place please write down del x1 by del m sorry del x1 by del m for this part the second part So I can split it into two parts, lambda P1 by P2 divided by H bar plus X2 into del X1 by del M. And
Yes, ma'am.
del X1 by del M. So finally, please check are we getting this?
Ma'am, it will be x2 minus x2 into del x2 by del m.
Because now I am getting in terms of x1, so it will be x2 into del x1 by del m. This has been done for, this has been written for commodity x2. So in your case, it will be del x1 by so you are getting this one?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So both the equations are done for x1. For x2, you have to derive the similar kind of equations. Okay. So please try this, please derive those two Slutsky equations too. One for x2 with respect to p2 and another for x2 with respect to p1. And that will complete the entire learning for Slutsky equation in a two commodity world. Actually, this Slutsky equation can be extended for n commodity world. In that case, instead of considering p vector as a function of p1 and p2, you have to consider the entire set of prices. Since we are discussing everything in terms of a two commodity world, so in your syllabus, you will have the solution for a two commodity world only. Okay, and you have this idea, if the cross effect is positive, in that case, the commodities are gross substitutes. If the cross effect is negative, in that case, the commodities are gross complements, so the net substitutability, gross substitutability. So all these things we did in the last semester. So you can go back to your theory class once again, and you can check the signs, etc. And you can check the notions of gross substitutability, net substitutability, so that you can match the entire thing, the theory and the mathematical part, the way we are deriving the Slutsky equation, everything becomes, very handy to all of you. Any question?
Excuse me, ma'am. Ma'am, lambda P1, P2 by D, ma'am, this is of one sign only, ma'am. So how we will get net substitutes or net complements?
So, you have to mention that, if this happens, in that case, I'll get this value. If this happens, you will get this value. In this way, you have to mention. Okay, in case of cross effect, clearly you will be able to talk about the gross substitutability, net substitutability, gross substitutability and gross complementarity. However, applying the notion of inferior commodity, normal good, the way we explained the entire thing in the theory context, in that way only you will be able to prepare your write-up. Okay. Okay, Oyan, got it?
No, ma'am. Ma'am, the first part, ma'am, how will it change signs? That is what I was asking. Means, in case of net substitute, it is positive. In case of net complement, it is negative. But if we observe this term, we are not getting that this change of sign will occur. Means, uh, in case we found it, it is negative always. So how we'll get it positive? Means this lambda is positive only.
Yeah, Lagrange multiplier is positive only. Yes.
So, ma'am, how this will change sign? That is what I was asking.
In this case, you are getting the negative sign.
Yes, ma'am.
And in the other case, you are getting the positive sign. No, I'm not getting your question. Okay, so please check everything. You please send your question in mail. Okay, so whatever the problem is there, I'll check it. Okay. So this is about the Slutsky equation. And next, we will move for constraint output maximization. Constraint output maximization, constraint cost minimization, this kind of exercises. So we are moving towards the production. So please go through the consumption part or utility part. And I hope you already solved the problems from the Henderson and Quant. Everybody solved it, completed this thing.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So please check everything. Whatever questions you have in your mind from the utility maximization part. So by this weekend, please jot down the questions and send it to me so that, Monday, I'll be able to answer to this question. Okay. So please send the questions by Sunday morning. Whatever questions, whether it is numerical problem related or whether it is, with respect to the theory and the mathematical part, whatever questions you have, please send the questions by Sunday morning so that I can address all these questions on Monday. So next I'm shifting for constant output maximization. Now, few ideas about the isoquant, isocost line, etc. So you did all these things in the last semester. Okay, since this slide is with the voice recording, so I have to show it in this format. If I, if I go for the slideshow version, in that case, the sound will be there and it will be difficult to tell you anything if everything goes simultaneously. Okay. So consider, is it visible or আরেকটু বড় করলে ভালো হয়? So consider a simple production function with two inputs, x1 and x2. So in these problems, x1 and x2 will be treated as inputs rather than commodities, as you know. And we are producing the output q. The production function can be stated as q is equal to f of x1, x2, where q is the quantity of output and small x1 and small x2 are the quantities of two inputs. The function f is continuous, so it is differentiable, has continuous first and second order partial derivatives. The function f is a regular, strictly quasi-concave function when output is maximized or cost is minimized, satisfying the condition f11 f2 square minus f1 f2 f12 plus f2 to f1 square is less than 0. Okay. For profit maximization, we considered f to be strictly concave function. However, when we are talking about the constant minimization, constant maximization problems, we are dealing with quasi-concavity, quasi-convexity, etc. So in case of unconstant optimization, we considered strict concavity, whereas in case of constant optimization technique, we are considering the quasi-concavity. Partial derivatives of f are strictly positive within the ridge lines, implying that marginal productivity of the inputs are positive. Within the two ridge lines, the marginal productivity of the two inputs are positive. In case of the utility maximization exercises, we considered for the goods, marginal utilities are positive. Here we are considering the fact that within the boundary of the ridge lines, within the bound of ridge lines, the marginal productivity of the inputs are positive. The equation to the isoquant will be given by f of x1, x2 is equal to a fixed quantity q naught. In general, it is q is equal to f of x1, x2. However, when we are considering isoquant, we are fixing the level of output and we are making it q naught. Totally differentiating the equation, we are getting the slope is given by minus dx2 by dx1 is equal to f1 by f2. Isoquant is negatively sloped. The ratio f1 by f2 is called the rate of technical substitution. In case of utility maximization, we call it MRS, marginal rate of substitution. Here we call it rate of technical substitution, RTS. The curvature of isoquant will be given naturally by the second order derivative del square x2 by del x1 square. So did you complete these exercises? In case of utility function, I told you to find out the second derivative.
Yes, ma'am.
Yes, ma'am.
সবাই করেছো? মনে হচ্ছে না।
Yes, ma'am.
Okay. যদি না করে থাকো করে ফেলো। The same thing, if you did it, you know this will be the expression as f2 greater than 0 and this f11, f2 square, etc. This part is negative by the quasi-concavity condition. The above expression is positive. I am considering f2 within the boundary of the ridge line, therefore it is positive. Thus, negative slope of the isoquant becomes larger algebraically and smaller in absolute value as x1 is substituted for x2. In other words, along the isoquant, if I move towards the rightward direction, the slope will become flatter and flatter. Another concept is important in context of production function, that is the notion of elasticity of substitution. Are you familiar with this formula, elasticity of substitution?
Yes, ma'am. Yes, ma'am.
Okay. So the elasticity of substitution, here I'm defining it by sigma, is measured by the rate at which substitution takes place. That is, it is proportionate change in input ratio divided by the proportionate change in RTS, rate of technical substitution. So it is del or d ln x2 by x1 divided by d ln f1 by f2. Okay, so this can be rewritten in this format. And this is positive. The elasticity of substitution is positive. Let's consider a producer purchases two inputs, x1 and x2, from a perfectly competitive markets at constant prices R1 and R2 respectively. We also consider B is the price of fixed unit used in production. In other words, B is the fixed cost part. So the cost equation, if I write, total cost will be the variable cost plus the fixed cost. The variable cost will be R1X1 plus R2X2. We are considering a competitive market, so remember R1 and R2 are exogenously given. So this is the required cost equation. So first we defined the output function, from there the isoquant, then some properties related to isoquant, and some issues related to the production function approach, and then finally we are defining the cost function. Once we get the idea of output function and the cost function, in the next step we can go for maximization of output subject to cost control, and thereby can derive the demand for two inputs, x1 star and x2 star. Okay, so if this is the cost function, the equation to the isocost line can be presented in this way. Okay, it is in y is equal to mx plus c format. So this is the equation to the isocost line. The slope of the isocost line is negative of the ratio of input prices. From this equation, I hope you are understanding, if you consider dx2 by dx1, that is the slope of the isocost line, that will be given by minus R1 by R2, or minus of dx2 by dx1 will be R1 by R2. So the slope of the isocost line is the negative of ratio of input prices. The firm maximizes output subject to the cost constraint. Thus, I can write the maximization problem in this format. Max Q is equal to f of x1, x2, subject to the cost constraint C naught is equal to R1, x1 plus R2, x2 plus B. Equilibrium will be achieved at the point of tangency between the isoquant and the isocost line. However, we will solve these two equations, or we will derive the values of x1 and x2 using the Lagrangian expression, because in that case we will be able to check the second order conditions, etc. So we will be able to claim the values of x1 and x2 we are deriving. These are output maximizing values subject to the cost constraint. So in the next step, I am going for the Lagrangian expression. So now you have, all of you have idea about the Lagrangian expression. So we will add the objective function with the constraint using the Lagrange multiplier. So this is our new objective function, or the Lagrangian expression, which is v is equal to f of x1, x2 plus mu, then c naught minus r1, x1 minus r2, x2 minus b. And as you know, if you like to write the constraint as r1, x1 plus r2, x2 plus b minus c naught format, in that case, you need to write minus mu of r1, x1 plus r2, x2 plus b minus c naught. That will be the format. Any question regarding the structure? Because once you understand this formatting, in the next step you have to go for first order conditions, combine the first two expressions and generate a fourth equation, solving third and fourth, getting the values of x1 star, x2 star. Then check the second order condition, that is consider all second order derivatives, and check whether the bordered Hessian determinant is positive here, because we are considering two input world. Otherwise it will alter in sign starting with positive. So any question up to this? Okay, so mu is the Lagrange multiplier, You know all these things. So I'm considering the first order derivatives, 1, 2, and 3. Dividing 1 by 2, we generate the equation F1 by F2 is equal to R1 by R2. Can you tell me, equation 4 indicates what? In case of the utility maximization, equation 4 indicates income consumption curve. And here, what does it mean?
Expansion path.
Expansion path.
Yes. Very good. So please add, this is the equation to the expansion path. Okay. Equation 4 is the equation to the expansion path. Now solving equation 4 with equation 3, we get the optimum values of x1 and x2. Now coming to the interpretation of Lagrange multiplier. Now mu can be written as f1 by r1 is equal to f2 by r2. Thus, Lagrange multiplier mu can be interpreted as the contribution of output of the last rupee spent upon each input. Okay, just like the utility maximization case. Okay, so in that case, value of the commodity, value of the last rupee spent on a particular commodity. Here, it can be interpreted as contribution to output of the last rupee spent upon each input. Worth of last rupee spent on each input. Worth of last rupee spent on each input in terms of contribution to output. The multiplier mu is also the derivative of output with respect to cost with prices constant and quantities variable. So, mu can be interpreted in a different way too. The Lagrange multiplier is also the derivative of output, dq by dc. Derivative of output with respect to cost with prices constant and quantities variable. So let's check this interpretation. Assuming the cost is variable, if you consider the fixed cost too, if you take the derivatives, dc, the fixed cost will drop down. So we are considering only the variable cost part. So assuming the cost is variable, the differential of the cost equation can be presented as dc is equal to r1 dx1 plus r2 dx2. Now substituting r1 is equal to f1 by mu and r2 is equal to f2 by mu. This above equation can be written as dc is equal to 1 by mu f1 dx1 plus f2 dx2. Totally differentiating the production function q is equal to f of x1 x2, we get dq is equal to f1 dx1 plus f2 dx2. So if this is the thing, from the production function we get this equation. Substituting dq in place of f1 dx1 plus f2 dx2, we can interpret mu as dq by dc. Simply, it is change in output due to change in cost. Change in output due to change in cost. Okay. So in context of production, mu can be interpreted as the worth of last rupee spent upon each input in terms of contribution to output, or it can be considered as, change in output, value added to the total output due to change in cost part, value added to the total output. Okay. So it is the interpretation in terms of output. The earlier one was the interpretation in terms of input, worth of last rupee spent on each input with, in terms of contribution to the output, in terms of their marginal product. And here, how the total output is changing with respect to change in cost. So how the value will be added to the output as there is a change in cost, as there is a change in spending. As I mentioned, solving 3 and 4, we will get the optimum values of the two inputs. Then you need to check the second order condition. Second order requirement is given by this border Hessian determinant. You are already familiar with this concept. In case of commodities, here you will have minus P1, minus P2, minus P1 and minus P2. And here, all the commodity prices has been replaced by the input prices. However, conceptually, everywhere, this is very, very similar to the earlier one. So this is all about the output maximization part subject to the cost constraint. This output maximization subject to the cost constraint is generally considered as the primal problem, whereas cost minimization subject to the output constraint is considered as the dual problem. So output maximization is the primal one, cost minimization is the dual one. The firm alternatively may like to minimize cost subject to the given level of output. The Lagrangian equation for the constraint cost minimization can be written as Z is equal to R1x1 plus R2x2 plus B, that is the cost path, plus lambda Q naught minus f of x1, x2. So here your constraint is the output, a fixed level of output you have to produce, or a fixed isoquant you need to consider, and then you are adjusting the cost to achieve that particular isoquant. So output level is fixed here, and we are trying to adjust the cost component or utilization of the input, etc., so that we can achieve that output level. Once we understand on the basis of the objective function and the constraint, we will get this Lagrangian expression. Next step will be to take all first order derivatives, del z by del x1, del z by del x2, and del z by del lambda, and set this to be equal to 0. We have to solve for 2 variables. However, we have 3 equations. So, to avoid the problem of redundancy, what we will do, we will divide equation 1 by 2, and we will get the equation R1 by R2 is equal to F1 by F2. The same equation we got earlier. F1 by F2 is equal to R1 by R2. Okay. So this equation. Now 1 by lambda is equal to F1 by R1 is equal to F2 by R2. Okay. And RTS, the rate of substitution is R1 by R2. R1 by R2 is called the rate of substitution. The Lagrange multiplier lambda is the reciprocal of mu in the output maximization problem. That is, it is given by dC by dQ. In the output maximization problem, it was given by dQ by dC, whereas in this case, it will be given by dC by dQ, dC by dQ. Okay, so this is all about the standard format of cost minimization. Now, if I come to the second order condition, we will get these expressions. If I consider the second order conditions, we will get these expressions. Substituting minus F1 is equal to minus R1 by lambda minus F2 is equal to minus R2 by lambda. Multiplying the first 2 columns of the array by minus 1 by lambda, and then multiplying the third row by minus lambda square, and the third column by lambda, we get this result. Actually, we are adjusting the things. We are adjusting the things. So if I replace lambda somehow, we are getting the result, you know, F11, F12 minus R1, F21, F22 minus R2 minus R1 minus R2 0. Okay, so this equation. Now this is same to the output maximization. Actually, what I can do, we can start with the second order condition, and then we can show an equivalence between the cost minimization and output maximization problem. Equivalence between the cost minimization and output maximization problem. So here, actually, the transformation I have done, or we have done, that is to show this bordered Hessian determinant is equivalent to the bordered Hessian determinant which we obtained in case of output maximization problem. Okay, so please look at these things, look at the states, do all these things, put the values, and you will get back this thing. Now, in case of utility, you know, when we are going for utility maximization subject to the income constant, we are getting Marshallian demand. However, when we are going for the other one, that is minimization of expenditure subject to the utility constant, we are not getting the Marshallian demand curve, rather we are getting the Hickshian demand curve. So conceptually, the two things are different. Here, you can look at the problem from the angle of output maximization subject to cost minimization, cost constraint, or alternatively, minimization of cost subject to output constraint. You will get the same values of input. You will get the same values of inputs. Okay, so here there is no difference, like, you know, we got in case of the earlier context. One is the Marshallian, another is the Hickshian. Here we will not get that kind of difference. The two input demands will be equivalent. You can derive the input demand all using any of the techniques, any of the alternative techniques. You can either go for output maximization subject to cost constraint, or you can go for cost minimization subject to output constraint. You will get the same result. So to tell you this point, you know, here there is conversion of the bordered Hessian determinant, which we are getting from the cost minimization part. And then if I readjust the columns, rows in a perfect way, we are getting back the second order condition which we got in case of output maximization. Any question up to this? Anyone, any question? Okay, one note you can take, you know, or you can remember one point. In case of unconstrained profit maximization, we also derived the input demands. Here also, when we are going for output maximization or we are going for cost minimization, we are deriving the demand for the inputs, you know. So these are the two ways, you know. In case of unconstrained optimization, if we start with the profit function, we can derive the input demands. In case of constraint optimization, if we go for output maximization subject to cost constraint or cost minimization subject to output constraint, in that case also we will be able to derive the input demand functions. So there are two channels by which we can derive the input demand. So if anyone have any question.
Ma'am, but both the input demand functions are different. One is the factor demand and other is the conditional factor demand. Means we are conditioning it that we have to meet this output.
Yeah, constant optimization. Yes, you are right. Here, subject to the constraint, you know, any value we cannot choose. Okay, any value we cannot choose. That was unconstrained factor demand, and these are constrained factor demands. These are conditional factor demands. Oyun is absolutely right, So there are two channels by which we can derive the factor demands. However, one is unconstrained and another is constrained. Okay, so if you do not have any question, after this, we have to go for some numerical exercises based on production function, cost equation, etc. Okay, so, so can I discuss one numerical exercise now, or it will be difficult for you?
Ma'am, can you please discuss the numerical exercise next day?
Yes, I can. So, you go through the theory part, complete the Slutsky equation part, and as I mentioned, whatever question you have, please jot down those questions and send the questions by Sunday morning, so that I can take care of all the questions you are sending. Tomorrow, I'll discuss the numerical exercises based on output maximization, cost minimization, etc. Okay. Once we understand how to do these problems, next you have to practice, you have to do some more problems. However, I'll shift for the value function approaches, the starting from value function, how we can proceed, so those approaches or those comparative statics we will start. So first we will solve 2 or 3 numerical exercises and then we will move for value function. So is it okay to all of you? Tomorrow I think I have classes from 3:30.
Yes, ma'am.
Yes, ma'am.
Okay. Okay, so in that case, tomorrow only I'll discuss the numerical exercise. Yes, Deeptosri, you raised your hand, so